Hello, welcome to Meki Techie. Learn as engineer, teach as champion. First of all, I would like to thank my family for their continuous support and encouragement of creating these kinds of technical videos in public domain. And I would like to thank my mentor, Professor R. Surendran from Government College of Technology, Coimbatore, for igniting me a spark of creating these kinds of technical videos in public domain. And I would like to thank Almighty my God for my good health and broad mind. And I would like to thank my friends, followers, my dear students and subscribers for their continuous support and encouragement. Today's topic of interest is unconventional machining process. We can say unconventional or non-traditional machining process. It is differ from the conventional or traditional machining process. First, we have to know the difference between conventional and unconventional machining process. For this, I would like to compare this conventional and unconventional machining process by means of a tabular column. So this is the parameters like the tools used. In conventional, there is a physical tool is used, either a multi-point cutting tool or a single point cutting tool or a grinding wheel. We have to use a physical presence of a cutting tool. In unconventional, may not be a physical tool present. The tool and workpiece contact. In conventional machining, direct contact between the tool and workpiece by means of a shear, it is machined. In unconventional, it does not require the direct contact. In terms of an accuracy, the conventional machining process will produce lower accuracy as well as the lower surface finish, where the unconventional machining processes uses higher accuracy and higher surface finish. In terms of a tool life, the conventional machining process, the lesser lifespan due to high surface contact and high surface wear. So the tool life in conventional machining process is too low when compared to unconventional. Here in the unconventional, greater lifespan due to low or no wear. In some of the process, it produce very low wear. In some of the processes, there is no tool wear. Waste material like chip, the higher waste material are being used or being produced by means of conventional machining. In unconventional machining, lower waste material. In machining processes like the changing the shape of a workpiece using an implement. So here what is meant by an implement? It is a single point or a multiple point cutting tool that is called implement made of harder material. Here you have to understand this point. The workpiece, the workpiece should be softer than the tool, or the tool is harder than the workpiece. Here in the unconventional, no harder tool is used. Sometimes the copper can machine a HSS like that. In energy sources, we have a mechanical energy is only available in the conventional machining. In unconventional, we can use mechanical, thermal, chemical, electrical energy like that we can use. Conventional machining, for your better understanding, the examples like turning, boring, milling, shaping, broaching, slotting, grinding, etc. All the processes are the examples of conventional machining process. In unconventional machining process like AJM, abrasive jet machining, water jet machining, electro discharge machining, electrochemical machining, ultrasonic machining, laser beam machining, and a lot more like that we are having. We have a very good classification of an unconventional machining process. This classification is based on what the energy is being used. Here the first one is the mechanical energy. The mechanical energy means erosion of the tool or erosion of the work material by means of a high velocity stream of abrasive or abrasives or fluids, or sometimes we can use both. So the erosion by means of a high velocity stream of abrasive or fluid can be used for machining the metals. Next one is the thermal. Here the thermal energy, that is heat. Heat is applied. When the heat is applied to the material will get fused and or vaporized. So it will get fused, melted, or sometimes vaporized by means of a heat. This heat energy, this thermal energy is generated by means of conversion of the electrical energy. The electrical energy is converted into heat energy. Next is an energy method. It is very simplest method. This mechanism is reverse of electroplating. It is just a reverse of electroplating. In the electroplating, we are coating a metal. In the electrochemical machining, we are removing the metal. In electroplating, we are adding the metal. In this electrochemical machining, we are removing the metal. That is why it is called as a reverse of electroplating. Next is a chemical method. So chemical method, the name itself we are having, the work material is attacked by means of some chemicals like an acids or an etchants. Like that, we use a very sensitive chemicals to the machined area where we have to machine. On that area we have to apply the chemicals, and we have removing the metal particles. The other portions are have to be protected by means of a mask. Next is that the classification of unconventional machining process in detail I am giving. Here I have abbreviated the processes like this. USM means ultrasonic machining, AJM means abrasive jet machining, WJM means water jet machining, wire cut EDM, EBM, IBM, that is ionization beam machining, LBM is a laser beam machining, PAM is the plasma arc machining, ECM electrochemical machining, ECG electrochemical grinding, ECH electrochemical honing, electrochemical deposition, and chemical machining. Like that, I have given different processes. Let us see where it can suited, but best suited. First is a mechanical energy method. In the mechanical energy method, we have ultrasonic, abrasive jet, water jet, and wire cut EDM is some of the processes which involves the mechanical energy method. Next is a thermal energy method, that is melting and vaporization. Here, the processes like EDM, EBM, IBM, LBM, PAM are used in thermal energy method. So heat is being used. In electrochemical method, that is ionization and abrasion. So in this electrochemical machining, electrochemical grinding, electrochemical honing, electrochemical discharging are being used, deposition are being used. In last method, we have a chemical method, that is etching process. Only chemical machining is being used. So with this detailed information, I like to go with the topics. I'm going to concentrate on 8 topics, 8 different machining processes which are available in the 4 different types. Here we have a first one is an ultrasonic machining. The high frequency electrical current is being coupled with the transducer coil. This transducer coil will, what will happen, we know the electrical current having some of the frequencies. Like the frequencies, it will get vibrating. The transducer coil will get vibrating. The transducer coil is connected with the vibrating tool or the tool holder. Here in the tool holder, this is the tool holder and tool. So here is the workpiece. The workpiece is filled with the abrasive slurry. Abrasive slurry like aluminum oxide or silicon carbide. Like that, any type of an abrasive is being applied between the workpiece and tool. The high frequency around 200 to 20,000 hertz of frequency is being given to the vibrating tool, the high frequency of vibration, it will dent the workpiece. It will dent the workpiece. The denting action, continuous denting action, will create the profile. So here the process parameters like metal removal, it is by means of an slurry of small abrasive particles forced against the workpiece by means of a vibrating tool. The work material like very hard and brittle materials like tungsten carbide, glass, quartz, germanium, ceramics, etc. are being machined by means of this ultrasonic machining. Tool material like low carbon steel, stainless steel is being used. Metal removal rate, it is 14 millimeters cube per second, and surface finish, it can produce zero point 0.2 to zero point 0.7 micrometers. Power requirement is low, capital cost is high, efficiency is high. The application like whenever the hard and brittle materials like glasses, ceramics, tungstens or have to be machined, we can straight away we can use the ultrasonic machining. The limitations, which is very simple: lower metal removal rate and higher tool wear. Here the abrasive particles also wear the tool also, so that is the greatest disadvantage in ultrasonic machining. Next is an abrasive jet machining. Here in the abrasive jet machining, a high pressure gas coupled with the abrasive powders, and it is mixed in the mixing chamber. The mixing chamber have to continuously vibrate it. That when it is having continuous vibration, then only the gas and the abrasive particles have to be mixed. And here we have a float control valve. The how much we have to supply, how much abrasive mixture have to be supplied is decided by means of the foot valve. And here we have a handle holder and nozzle. The high velocity of the abrasive and gas stream hits the workpiece and also makes the dent. So like that, the abrasive particles hit hard on the work material and it will get machined. So like that, abrasive jet machining is being used. The abrasive particles are forced as a jet, as a jet of a fluid, as a jet of an air. The abrasive particles hit and concentrate on the point of a work material, then it will get machined. Here we have some process parameters we have to know about abrasive jet machining. The metal removal technique by means of a high stream of abrasive particles mixed with air. The most of the time air is being used, or some of the inorganic gases like helium, argon, or can be used. The work material like a hard and brittle material like glass, quartz, ceramics are being used. Tool material like it is an abrasive tool, right? It is an abrasive particle, right? Either aluminum oxide or silicon carbide or sometimes glass powders can be used. The metal removal rate, it is very low when we compare to abrasive jet machining. It is 100 times, 1000 times lesser than ultrasonic machining, that is 0.014 millimeter cube per second, and surface finish 0.5 to 1.2 micrometers. Here the power requirement is low, capital cost is also low, the efficiency is good and very high. That is why the applications like making an intricate holes shape in a hard and brittle materials, we can use this abrasive jet machining. The limitations is the accuracy and the metal removal rate, lower metal removal rate and lower accuracy. The next one is the water jet machining. The difference between abrasive jet and water jet, there an abrasive particles are used. Here there is no abrasive particle. Water is pumped at the high velocity around 7000 meter per second of velocity of water is hit hard on the workpiece, then it will generate a hole and it will machine it, and whatever the profile it can machine. The major disadvantage is we cannot use this technique for the high thickness material. If a thickness of the work material is very small, we can straight away use this water jet machining. And also here the high pressures are being used. So the safety wise we have to be very careful on water jet machining. Here some of the process parameters and process parameters about water jet machining. The metal removal technique is high velocity of water jet. As I said earlier, 700 meter per second of velocity is being handled. Work material like soft non-metallic metal like plastic, paper boards, etc. is being used. Tool, water jet. Tool is the water jet. And metal removal rate, it is bit better than abrasive jet machining, and 0.6 millimeter cube per second. Surface finish 0.5 to 0.8. Here the power requirement is high capital cost, high efficiency, and the non-metallic materials can be easily machined by means of water jet machining. And the major disadvantage is it is difficult to machine harder materials. Next is a electro discharge machining. Here we have an electrode. It is connected with the negative source and a positive source to the workpiece. So workpiece is in the positive source, and we have a very small gap. We have a very small gap between the electrode and the workpiece. In this, a high frequency of current is being jumped from the workpiece to cathode electrode. That is why the profiles are being cutted. So in order to enhance this, and we have to enhance the transferring of energy, electrical energy, as well as controlling the gap and controlling the spark, we are using an electrolyte. So electrolyte, dielectric fluid like kerosene we have used. So the kerosene is forced or pumped on between the anode and the cathode, and we have a continuous feed for the electrode in order to make the profile. So this electro discharge machining, which is very good for making profiles. It is very good for making the profiles. A small gap and jumping of the electrons will produce the profile. It is very simple, we can understand. And a reverse of welding process, a reverse of welding process. In welding, the metal is being poured or metal is being supplied between the two work material. Here the material is removed. That is the very basic difference. Here the process parameters about EDM. Metal removal technique by powerful electrical jet. Workpiece, the work material, whatever the material, maybe metallic or non-metallic or an alloy, if it is good in electrical conductive materials, then we can use EDM. Tool material like copper, yellow brass, alloy, zinc are being used. Zinc, copper, tungsten, etc. are being used. Metal removal rate is 15 to 80 millimeter cube per second. Surface finish is 0.25 micrometer can be achieved. The power required, which is very low, capital cost is medium, good efficiency. That is why very complicated and irregular shapes can be done. Resharpening of cutting tool, very hard cutting tool can be easily done. The limitation is it is suited for conductive material, therefore non-conductive material cannot be used. Next, an electron beam machining. A high velocity of electron beam is concentrated on the work material. Since the work material have to be produced in the vacuum chamber, in vacuum the high velocity of the electrons have been concentrated on the single point. For this purpose, the magnetic lens is being used. The magnetic lens is used for concentrating the high velocity of electrons on the workpiece. So here the melting and the vaporization is being happened. So at the high velocity, the electrons are bombarded in the workpiece. Therefore, it produces the heat. Those heat, it can generate any profiles. So here very important is a vacuum, magnetic lens, and high velocity of electron stream is being used. So here the process parameters about EBM is the high velocity metal removal technique by means of high velocity beam of electrons. Work material, all material we can use, but the limitation is it is not suitable for high thickness material, because very high material, high heavy materials we can't produce any vacuum. So vacuum is also a disadvantage. We have to produce a perfect vacuum, or else if the vacuum is failed, the scattering of electron is being done. We cannot concentrate the electron particles in the particular point. Therefore all tool material can be used, all work material can be used. Tool material is the electron beam, and metal removal rate is bit higher, 15 to 40 millimeter cube per second can be measured. Surface finish like zero point 0.4 to zero point 0.6 micrometer can be measured. Low power requirement, high capital cost, very high efficiency. Micro machining on thin drilling, like thin drilling, slotting and scribings are being used in, can be produced by means of electron beam machining. Next is a laser beam machining. Here the laser beam is being produced and it has been concentrated on the workpiece material, and also melting and vaporization is being used. Here for producing the laser, the ruby crystal is used. Ruby crystal is covered with 100% reflecting mirror as well as the partial reflecting mirror. So the ruby crystal will produce laser in a scattering form. This flash lamp produces the ruby crystal will glow heavily. So here the laser beams will go up. The 100% reflecting mirror reflects the laser to the lens, and the lens will get helps in concentrating the laser beams into the work material. So like that the laser beam is being used. Here the process parameters for the LBM is being discussed. The metal removal technique by means of high intensity of laser beam. Work material, all materials except high thermal conductive and high reflective materials can be machined. Tool material is a laser beam. The metal removal rate it is 15 to 40 millimeter cube per second. Surface finish produce very good surface finish like zero point 0.4 to zero point 0.6 micrometer. Power requirement is very low. Capital cost is high. Efficiency is high. The application like micro drilling of micro holes up to 250 micrometer can be drilled, and cutting very narrow slots can be done. The limitations is there is a taper, there is a chance of a taper produced, taper of 0.05 millimeter when the work thickness is more than 0.25 millimeter can be the disadvantage of the LBM process. Next is a plasma arc machining. The high velocity of the plasma is being used to cut the workpiece or to machine the workpiece. The high temperature, here the high temperature is being used. That is why we have to circulate the water shield on the plasma. So plasma gas, so here the plasma gas is used. Gas is being uh, generated the plasma arc by means of an electrodes. Here the process parameters of PAM is The metal removal technique is heating, melting and vaporization by using plasma, and the tool material is the plasma. Work material, all material which conduct electricity. And metal removal is very high metal removal, 2500 meter cube per second, and very rough surface is being produced. Surface finish is very poor. Power requirement is very low, capital cost is very low, efficiency is low because of the surface finish. The application like profile cutting, a rough profile cutting on the stainless steel, monal or a super alloy plates, we can use plasma arc machining. Limitation, as we know that poor accuracy is the major limitation of PAM. Next is a electrochemical machining. Here electricity as well as the chemicals are being used. Here the electrolyte is being circulated on the workpiece, and also workpiece is connected with anode, and the tool is connected with the cathode. So DC supply is being used. The flow of the electrolyte as well as the DC power supply will remove the uh, unwanted material from the workpiece. So here the workpiece is also machined as well as the tool is also machined. So that is why the tool is covered, the sides of the tool is covered by means of non-reactive material to the electrolyte. So like that we have to use the UV, use electrical as well as the chemical energy. Their process parameters, and process parameters on ECM is the metal removal technique is based on Faraday's law of electrolysis. The work material difficult to machine. What are the materials which is difficult to machine and conduct electrically conducted as well as difficult to machine, we can use that workpiece in the ECM process. Tool material like copper, brass, tungsten copper or copper tungsten, stainless steel are being used. Metal removal rate is 27 millimeter cube per second. Surface finish 0.2 to 0.8 micrometer. Power requirement is minimum. Capital cost is high. Efficiency is low. The application, very hard and complex shaped parts can be machined. And the disadvantage is not suitable for non-conductive material. So if you have any queries, please let me know in the comment section. If you like this video, you can share and subscribe the Meki Techie channel for the continuous update. And thank you all.